Happy spring break. This is a quick lesson on lesson 7, which is about solving quadratics by finding square roots. So this is on page 25 of your gym packet. Let's go for it. So some of this should look familiar, especially if you see the example here that it's x squared minus 49. Some of you, your spidey sense might go off and you might think, well, that looks like a difference of squares. I wonder if that's going to be related to solving quadratics by finding the square roots. So there really are two different ways to solve these, but I'm going to teach you a different way as well. And I will return the idea to the whole idea of difference of squares in a few minutes. But again, this is lesson 7, page 25. So quadratics in the form, or of the form, of ax squared plus c equals 0. Notice what's missing from this. So if I analyze this, if I look at maybe standard form, remember standard form is something like ax squared plus bx plus c, right? What's missing from this form is the bx term. This can be solved in a different way. So if I look at some of my steps, so first of all, if I identify that I have this form and it's set to 0, what I can do is I can isolate my x squared. In other words, I could say, well, am I just solving for x like my other work that I've done in this unit and the past couple of lessons? Well, yes. So in essence, I'm solving, right? Solve for x. And then you're going to take the square root of both sides. So let's start with x squared minus 49. Well, if I want to isolate, and I can do it out in steps, if I want to isolate my x squared, I can simply add 49 to both sides, and I will get x squared equals 49. Now it says to take the, so I isolated. Now it says to take the square root of both sides. Well, what I do one side, I should do the other side because I'm balancing all equations. Well, what's the square root of x squared? Well, it's x. And then what's the square root of 49? Well, it is 7. Now, this is where it can be a little tricky because 49 actually has 2 square roots, meaning 7 squared equals 49. And so does negative 7. So negative 7 squared is also equal to 49. So what would make this true up here would be both the plus and minus, or positive or negative 7. And my final answers, because we are looking for that set form, the final answer for this would be x is equal to a set, right, of 7 and negative 7. And that's how I would indicate that. You will see different ways to express this. Some ways you'll just see this sometimes. You'll see it in set form other times. So down here, let's look at number 1 together. So x squared minus 16. Well, x squared equals, I'm going to add 16. I'm basically moving that 16 to the other side. If I take the square, oh my god, that's like a weird root. That would be x is the square root of 16, so I would say that it's positive or negative 4. Here I could write that x is equal to a set of 2 numbers, which is negative 4 and positive 4. Hopefully you'll recognize this. X squared equals 100. Take the square root of both. X is equal to positive or negative 10. X equals negative 10 and 10. So this is fairly straightforward. There is another way to do this. If I want to take this one for a moment, this x squared minus 100, and I just want to point something out. In one of our last lessons, we learned that if you find the factors, I can find the solutions by factoring. Could I look at this, and can I find the two factors that would get this fairly quickly? Pretend this is a binomial, right, that you're needing to factor. Well, some of your spidey sense should go off. This is all a difference of squares, right? I could take the square root of x squared, and I could take the square root of 100. Well, what if I do this? Can I just take the factors and set them both to 0 like we did previously? Yeah, I could. So x plus 10 and x minus 10. That's a way I can factor this expression, or this equation up here. Now, following my rule, I can set both sides to 0, or both expressions to 0, and solve. So x equals negative 10, or x is equal to positive 10. And guess what? That means the same exact thing. So that would mean x is equal to the set of negative 10, positive 10. So there are two ways to do this, and you can decide which way you like better. This is the difference of squares and setting to 0. So if this is in factoring, and setting to 0. So that is, I mean, for me personally, if I see a difference of squares just like this, I might use this method because I recognize that pretty quickly what that is. For some of you, you might like this one better, right? That you're just going to solve for x up here. Either way works, as you can see. So it's really about what's going to be more efficient for you. So now let's look here. So number 3 is going to be a little different. So if I isolate, first of all, it's not a difference of squares, but I can go ahead and isolate. I'm going to subtract 25. I'm going to have x squared equals negative 25. Let's take the square root, take square root. X is equal to, oh gosh, now I have a negative 25. Does a negative number earn me a square root? Is there any number, like 5 times 5 is 25. Negative 5 times negative 5 is still 25. Negative 5 times 5 is, well, it's negative 25, but these are not roots. These are not the same numbers. There's no real solution to this. You are going to learn later that there are imaginary solutions to this, but for you and your purposes right now, there is no real solution to that if it's negative. And this should sound familiar to what we did with the discriminant. If you plugged some values into that b squared minus 4ac, and you try to solve it, and maybe you end up with a negative number as a discriminant, there is no solution. So this goes to say that this is similar. Now, for number 4, this looks a little different. It's not a difference of squares. I am going to isolate my x squared. Oh, I like this one. I was hoping they were going to do this. 88 minus 7. Well, that's a nice square number, 81. So I'm going to take the square root of both. Now, x equals positive or negative 9. So my set, and again, this is a set, not a coordinate pair, is that. And remember, it's a square root. You should have a negative number and its opposite. Let's go ahead to number 6. Because now I'm going to have to divide. So if I isolate my x squared, I'm going to divide by 6. 54 divided by 6 is 9. Take square root of both sides. X is positive or negative 3. X equals negative 3, positive 3. If I have a fraction here, I mean, we could do that. How would you isolate? Could you, in fact, let's see, if it's a fraction here, I am going to Well, I have to divide by 3/4, don't I? So let's go ahead, let's pretend I'm dividing by 3/4. If I have to just divide 48 divided by 3/4, I could solve that by even doing this, right? This also means 48 times the reciprocal. Well, does 3 go into 48? Oh, someone is texting me about something interesting. Okay. Where was I? Oh, my light just went off. Okay, so over here, what I could do here, first of all, I could ask myself, well, could I do any cross simplifying here? Yes, I can. So again, 48 divided by 3/4 is the same thing as 48 times the reciprocal, or 4/3. Now I can try to simplify. 3 goes into 48 16 times. Now I can just simply, because I'm multiplying fractions, multiply across. 16 times 4 is 64 over 1. Okay, so x² equals 64. And then I can take the square root of both, and it's x equals positive or negative 8. So my set here is negative 8 and positive 8. So you're going to have to do some arithmetic. You're going to have to look at something like this. You're going to have to get 45 alone. You're going to have to divide by 5. But you can look at the answer key for the rest of those. But I think that will get you at least off to a good start. I will model some of that homework now.